11. Geometry and measurements. Topic 2. An introduction to trigonometry. The objectives for this topic are to know the trigonometric ratios of sine, cosine and tangent, and to know the special values of sine, cosine and tangent for certain angles. If we know one of the angles in a right-angled triangle, we can use it to find the ratios of the sides. To do this, we need to label the sides so that we know which ones we're talking about. This one is the hypotenuse, the one opposite is called the opposite, and the one next to the angle is called the adjacent. Now, if the triangle gets bigger or smaller, but the angle stays the same, then the ratio of the sides stays the same. We can work out these ratios using functions called sine, cosine and tangent. The ratio of the opposite and the hypotenuse is called the sine of the angle, or sine x. The ratio of the adjacent and the hypotenuse is called the cosine of the angle, or cos x. And the ratio of the opposite and the adjacent is called the tangent of the angle, or tan x. For example, in this triangle, the hypotenuse is 10, the opposite is 6, and the adjacent is 8. So sine x is 6 over 10, cos x is 8 over 10, and tan x is 6 over 8. Try these questions. What is cos x for this triangle? What is tan x for this triangle? If tan A equals 3 over 4, calculate cos A and sine A. Pause the video whilst you work out the answers. Here are the answers. For number 1, cos x is the adjacent, which is 3, over the hypotenuse, which is 8. So cos x equals 3 over 8. For number 2, tan x is the opposite over the adjacent, which is 3 over 7. For number 3, we should draw a picture first. Tan A is 3 over 4, so the opposite over the adjacent is 3 over 4. We can then use Pythagoras to find that the hypotenuse is 5. So now cos A is 4 over 5 and sine A is 3 over 5. If the angle in a triangle is 45 degrees, then the right angle is 90, and so the missing angle must also be 45. And we have an isosceles triangle where this side is also 1. We can find the hypotenuse using Pythagoras. 1 squared plus 1 squared equals c squared. 2 equals c squared. C equals the square root of 2. We can then use this to write the ratios for sine x, cos x, and tan x when x equals 45. Sine of 45 is 1 over the square root of 2. Cos of 45 is also 1 over the square root of 2, and tan of 45 is 1 over 1, which is 1. If we start with an equilateral triangle, we know that all the angles are 60 degrees, and we can create a right-angled triangle by splitting the triangle down the middle. Now, if we call the height h, we can use Pythagoras to find h. 1 squared plus h squared equals 2 squared. So h squared equals 3. So h equals the square root of 3. We can now find sine, cos and tan of 30 and 60. We'll start by using this angle here, 30 degrees. Sine 30 is the opposite over the hypotenuse, which is 1 over 2, or half. Cos 30 is the square root of 3 over 2. Tan 30 is 1 over the square root of 3. And we can find all of these by just using this triangle here on the left. We now use the 60-degree angle. Sine 60 is the square root of 3 over 2. Cos 60 is 1 over 2. And tan 60 is the square root of 3. We can also find sine, cos and tan for 0 and 90 degrees. Start with an isosceles triangle where both sides have length 1. Start by making the triangle shorter so that the height is smaller, and go all the way until the height is 0, and in this case the hypotenuse and the adjacent will both be 1. So sine of 0 is 0 over 1, which is 0. Cos of 0 is 1 over 1, which is 1. And tan of 0 is also 0. If instead we make the triangle taller, so that the width gets smaller, and we go all of the way until the width is 0 and the hypotenuse is also 1, then we can say that sine of 90 is 1 over 1, which is 1. Cos of 90 is 0, and tan of 90 is 1 over 0, which is infinite or undefined. To summarise, sine of x is the opposite over the hypotenuse, cos of x is the adjacent over the hypotenuse, tan of x is the opposite over the adjacent. Sine, cos and tan of 0, 30, 45, 60 and 90 all have specific values. Try these questions to finish off with. Evaluate sine 60 cos 30 plus sine 30 cos 60. True or false? Sine of 2 times 30 equals 2 times sine 30. A ladder 30 metres long leans against a wall and makes an angle of 30 degrees with the ground. How high up the wall does the ladder reach? Pause the video whilst you work out the answers. Here are the answers. For number 1, work out each part separately. So it's the square root of 3 over 2 times the square root of 3 over 2 plus a half times a half, and this simplifies to 1. For number 2, sine of 60 is the square root of 3 over 2, but 2 times sine of 30 is 2 times a half, so it's false. For number 3, we need a picture. The ladder here is 30 metres long, the angle with the ground is 30, and this distance x is what we want to find. If we use the ratio for sine, we can say that sine of 30 is x over 30. Sine of 30 equals a half, so a half equals x over 30, and x equals 15 metres. And just check in the diagram that this value looks sensible. 15 metres here is about half of this length here, so yes, that looks sensible. This is the end of topic 2. Unit 7, Geometry and Measurements. Topic 3, Solid Figures. The objectives for this topic are to know the definitions of pyramid and cone, and to know how to find the surface area and volume of a right pyramid and a cone. For a pyramid, you start with any shape for the base. It has to be some kind of polygon. A pyramid is then formed by joining all of the vertices or corners of the polygon to a single point outside the plane of the polygon. For example, these corners are joined to this point, these corners are joined to this point, and these corners are joined to this point. If we start with a circle and join every point on the circumference, of which there are infinitely many, to a single point outside the plane of the circle, then we get a cone. We name pyramids depending on their base. This is a quadrilateral pyramid, a triangular pyramid, some kind of irregular pyramid, and a cone. Here's a diagram showing the parts of a pyramid. The shape at the bottom is called the base. The sloping faces are called the lateral faces. The sloping edges are called the lateral edges. The point at the top is the vertex. This height here is the slant height, L, and the vertical height is the height or altitude. Right pyramids are a special case of pyramids. They must have a regular base. So this example here is no good because the base is irregular. It has sides of different lengths. So we could try this one instead, which has a square base. It must also have all lateral sides the same length. So this one is no good because this lateral side here is longer than this lateral side here. So we could try this pyramid instead. This time it has a regular square base and all of these lateral sides are the same length. So this is a right pyramid. Try these questions. Draw a cone and indicate the base, the lateral face, the altitude, the slant height, and the vertex. What is a right circular cone? What is an oblique circular cone? Pause the video whilst you work out the answers. Here are the answers. Here is a cone. This is the base. Around the edge here is the lateral face. This vertical height is the altitude. This sloping height is the slant height. And this point at the top is the vertex. A right circular cone is a cone with a circular base where all the lateral sides have equal length. An oblique circular cone is a cone with a circular base but with lateral sides of different lengths. We can find the surface area of right pyramids. We start with the lateral surface area. So this is the area of all of the sloping faces. The formula for this lateral surface area is a half PL, where P is the perimeter of the base and L is the slant height, labelled here on this diagram. If we then add on the area of the base, we can say that the total area, AT, equals the base area, AB, plus the lateral surface area, AL. We can also use this formula for cones, and in this case, the formula has a special form. P, the perimeter of the base, is now the circumference of this circle, which is 2 pi r. So the lateral surface area is a half times 2 pi r times L, which simplifies to pi RL. If we then put that into the total formula, we find that the total area is the area of the base, or pi r squared for the circle, plus the area for the lateral sides, which is pi RL. There's also a formula for the volume of a right pyramid and a cone. The volume is 1/3 times the area of the base times the height, and this h height is the vertical height or altitude. For a cone, again, this has a special value. AB this time is the area of the circle, which is pi r squared. So we can write that the volume is 1/3 times pi r squared times h. To summarise, the surface area of a right pyramid is AB plus a half PL, where AB is the area of the base and a half PL is the lateral surface area. The surface area of a cone is pi r squared for the base plus pi RL for the lateral surface area. The volume of a right pyramid is 1/3 times the area of the base times the height. The volume of a cone is 1/3 pi r squared h. Try these questions. Which of these is a pyramid? A regular square pyramid has all its edges 10 centimeters long. Find its total surface area. A right circular cone has altitude 8 centimeters and radius 6 centimeters. Find its volume. Pause the video whilst you work out the answers. Here are the answers. This one is a pyramid. This is not a pyramid because the vertices of one side are not all connected to the same point. The same for this one, and this triangle is not even three-dimensional. For number 2, the total area is the area of the base plus the lateral surface area. For the base, it's a square, so 10 times 10. For the lateral surface area, we do a half times the perimeter of the base times the height. This simplifies to 300 centimeters squared. For the third one, we use the formula for volume, which is 1/3 times pi r squared times h. So 1/3 times pi times 6 squared times 8, which is 301.6 centimetres cubed. This is the end of topic 3.
Welcome to Grade 8, Unit 7 Cyber Class. This video contains a summary of the unit and review questions. This educational material is produced by E. Fanos, and your teacher for this course is Jane Goodland. A summary. Euclid's theorem says that AC squared equals AB times AD. Pythagoras' theorem says that A squared plus B squared equals C squared. Sine of x equals opposite over hypotenuse, cos of x equals adjacent over hypotenuse, and tan of x equals opposite over adjacent. And now let's have a look at some review questions. Question 1. In the figure given below, ABCD is a square with diagonal AC equals 8 root 2 centimetres long. What is the length of a side of the square? Pause the video whilst you work it out. Here's the solution. Since ABCD is a square, then triangle ABC is a right-angled triangle and the four sides of the square are equal. AC squared equals AB squared plus BC squared by Pythagoras' theorem. So AC squared equals 2AB squared because these two lengths are the same, which means that AB equals the square root of AC squared over 2, which is equal to the square root of 64 times 2 over 2, which is 8 centimetres, so the answer is B. Question 2. Which of the following is equal to cos 60 degrees? Pause the video whilst you decide. Here's the solution. Here's a picture showing the different angles in the triangle. Since 30 degrees and 60 degrees are complementary angles, then they both appear in the same right-angled triangle. Cos of 60 is equal to adjacent over hypotenuse, which is B over C. And this is the same as sine 30, which is opposite over hypotenuse, so in this case, B over C. Sine of 60 is equal to A over C, and that's the same as cos of 30. And tan of 60 is equal to A over B, which is the same as cot of 30. So the answer is C. Cos 60 equals sine 30. Question 3. The angle of elevation of the top of a telephone pole from a point on a level ground 12 metres away from the foot of the pole is 60 degrees. How high is the telephone pole? And here's a diagram showing this information. The foot of the pole is 12 metres away from the point, and the angle of elevation is 60 degrees. Pause the video whilst you work it out. Here's the solution. We need to use tan 60 to get h over 12, because tan is equal to opposite over adjacent. This means that h equals 12 times tan 60, or 12 root 3. So the answer is A, 12 root 3 metres. Question 4. A solid figure formed by joining all points of a circle to a point not on the plane of the circle is called a pyramid, a cylinder, a prism, or a cone. Pause the video whilst you decide. Here's the solution. It's a cone. A cone is a solid figure formed by joining all points of a circle to a point not on the plane of the circle, as shown on the screen. So the answer is D. Question 5. The lengths of the legs of a right-angled triangle are 9 cm and 12 cm long. What is the length of the hypotenuse? Pause the video whilst you decide. Here's the solution. Here's a diagram. The lengths of the legs are 9 and 12. We need to use Pythagoras' theorem, which says that AC is equal to the square root of AB squared plus BC squared. In this case, that's 9 squared plus 12 squared, or 81 plus 144. So AC is equal to the square root of 225, which is 15 centimetres. So the answer is B. Question 6. In the figure below, triangle PQR is right-angled at R. Which one of the following statements is not true? X equals 6, sin P equals 3/5, tan Q equals 4/3, cos Q equals 4/5. Pause the video whilst you work it out. Here's the solution. By Pythagoras' theorem, PQ squared equals RQ squared plus PR squared, which means that 100 equals X squared plus 64. So X is equal to the square root of 100 minus 64, or the square root of 36, which is 6 centimetres. So A is true. Sin P is equal to opposite over hypotenuse, which is 6 over 10, which is 3 over 5. So B is true. Tan Q is equal to opposite over adjacent, which is 8 over 6, which is 4/3. So C is true. Cos Q is equal to adjacent over hypotenuse, which is 6 over 10, or 3/5. So D is not true. So the answer is D. Question 7. Which one of the following statements is not necessarily true about a regular pyramid? Its lateral faces are all equilateral triangles. Its base is a regular polygon. Its lateral edges are equal in length. And it is a right pyramid. Pause the video whilst you decide. Here's the solution. Look at this picture of a regular pentagonal pyramid. To have a regular pyramid, the following 3 conditions must be satisfied. The pyramid must be a right pyramid, that is, the foot of the altitude must be at the centre of the base. The base of the pyramid must be a regular polygon, and the lateral edges of the regular pyramid are all equal in length. So the answer is A, because all of the other possibilities are true. Question 8. In the figure, triangle ABC is right-angled at C. If AB equals 3x minus 2, AC equals 2x plus 1, and cos A equals 3/4, then what is the value of x? Pause the video whilst you work it out. Here's the solution. Cos A equals adjacent over hypotenuse, so in this case it's CA over AB, which is 2x plus 1 over 3x minus 2. And we know that this is equal to 3/4 because we are told this in the question. If we rearrange this equation here, then we get 4 times 2x plus 1 equals 3 times 3x minus 2, which means that 8x plus 4 equals 9x minus 6, which means that 10 equals x. So the answer is B. X is 10 centimetres. Question 9. In the figure below, triangle ABC is right-angled at C, and CD is an altitude of triangle ABC. If the length of CD is 12 centimetres, and the length of AD is 9 centimetres, what is the length of BD? Pause the video whilst you work it out. Here's the solution. By Pythagoras' theorem, we know that AC squared equals DA squared plus CD squared. That's for this triangle here, which means that AC is equal to the square root of 81 plus 144, which is 15 centimetres. Then by Euclid's theorem, AC squared equals AB times AD, which means that AB is equal to AC squared over AD, or 225 over 9, which is 25 centimetres. BD equals AB minus AD, which is 25 minus 9, which is 16. So the answer is D, 16 centimetres. Question 10. In the figure below, triangle ABC is right-angled, with CD perpendicular to AB. If the length of AD is 4 centimetres and the length of BD is 12 centimetres, then what is the length of AC? Pause the video whilst you work it out. Here's the solution. By Euclid's theorem, AC squared equals AD times AB. AD is 4 centimetres and AB is 4 plus 12. So 4 times 4 plus 12 is 64 centimetres, which means that AC is 8 centimetres. So the answer is D, 8 centimetres. Question 11. A ladder of length 12 centimetres leans against a wall so that the angle between the ladder and the wall is 60 degrees. How far is the base of the ladder from the wall? Pause the video whilst you work it out. Here's the solution. Here's a picture of the ladder. This is the wall, and this is the ladder of length 12 centimetres. We need to find this length here, x. Sine 60 is equal to the opposite over the hypotenuse, so in this case x over the length of the ladder, which means that x is equal to 12, the length of the ladder, times sine 60, which means that x is equal to 12 times the square root of 3 over 2, or 6 root 3. So the answer is C, 6 root 3 centimetres. Question 12. In the figure, triangle XYZ is right-angled at Y. If the length of XY is 5 and the length of XZ is 13, then which of the following is true? Cos Z equals 5 over 13, tan X equals 13 over 5, sin Z equals 12 over 13, or tan Z equals 5 over 12. Pause the video whilst you work it out. Here's the solution. By Pythagoras' theorem, 13 squared equals 5 squared plus yz squared, which means that yz is equal to the square root of 169 minus 25. So yz is equal to the square root of 144, or 12 centimetres. So that's this length here. This is 12 centimetres. Cos z equals 12 over 13, tan x equals 12 over 5, sin z equals 5 over 13, and tan z equals 5 over 12. So the answer is D. Question 13. In the figure, triangle ABC is a right-angled triangle with altitude CD. If CD is perpendicular to AB, then which of the following is not true? BC squared equals AB times BD, CD squared equals CB squared minus DB squared, AC squared equals AB times DA, or AB squared equals AC times BC. Pause the video whilst you work it out. Here's the solution. Based on Euclid's theorem, BC squared equals AB times DB, and AC squared equals AB times AD. So this means that A is true, and also C is true. Based on Pythagoras' theorem, AC squared equals AD squared plus CD squared, and BC squared equals DB squared plus CD squared, which means that CD squared equals CB squared minus DB squared. So B is true. So the only one which is not true is D. Question 14. In the figure below, triangle ABC is right-angled at C. If the length of BC is 6 centimetres and the length of AB is 10 centimetres, then which of the following is true? Sin A is 3/5, tan B is 3/4, cos B is 4/5, or tan A is 4/3. Pause the video whilst you decide. Here's the solution. Based on Pythagoras' theorem, AB squared equals BC squared plus AC squared, which means that 10 squared equals 6 squared plus AC squared. So AC is equal to the square root of 100 minus 36, or the square root of 64, which is 8 centimetres. Then sin A is 6 over 10, or 3/5, tan B is 8 over 6, or 4/3, cos B is 6 over 10, or 3/5, and tan A is 6 over 8, or 3/4. So the one which is true is A. Sin A equals 3/5. This is the end of Unit 7.